I'm Chris, and in this lesson we're going to be taking a look at another related rates question. The last video that we did had to do with triangles and Pythagorean theorem. Here we're going to look at a slightly more complex geometric figure. We're going to be looking at a cone. This question, if you're using the Larson calculus book, this is on page 155, 156. It's question number 20 from the chapter and section on related rates. And in this question, they tell us a lot of key information about this cone. To be honest, in my opinion, I think they tell us a little too much information because they do give you the formula for volume of a cone. I didn't put that on the board yet because I'm going to quiz you on it and see if we can come up with that from memory, since that's definitely something that you will need to know when you're dealing with related rates questions. So for right now, in our picture, they tell us in part A of the question, they want to know what's happening when the radius is 6. So we've got a radius of 6. They tell us in the problem that 3r equals h, which means that the height is going to be 3 times the radius for this particular cone. And they tell us the change in radius over time is 2 inches per minute. So that's how fast our cone is increasing in size. That's how fast the radius is growing. And this is the kind of question that you oftentimes see where maybe you have a cone-shaped container and you're filling it with water. So maybe when the water gets up to a particular height, or when the radius of the water in that cone-shaped container is a particular value. That's sort of the scenario where you're likely to see this tested. Not in this particular question, they just describe it as a general cone, but on an AP exam or maybe on a test that you have in class, that's what you're likely to see as far as the kind of scenario where this gets tested. All right, so let's jump in and take a look. Whenever we're dealing with cones, in this case, we want to take a look and see if we can come up with the volume equation for a cone. And in this case, volume of a cone is going to be 1/3 pi r squared h. Hopefully that's what you said out loud or to yourselves as I was putting that up on the board. So volume of a cone is 1/3 pi r squared h. And a lot of times, I like to, in my mind, relate a cone and a cylinder to each other. A cylinder has a volume of pi r squared h, so a cone is just 1/3 of that. If you can kind of picture in your mind sort of taking a cylinder and arranging 3 cones to kind of fill that cylinder up, it's a good way to memorize those two equations. So for this particular question, what we're being asked to do is we're being asked to find the change in volume over time. So when the radius is 6, we want to know what is dV dt. That's what we have to figure out. And in order to do that, we're going to have to take the derivative of this volume expression. So if you start and go to take the derivative, you'll notice that you have 2 variables, which would mean you have to use a little bit of product rule and implicit differentiation. And you're going to end up with a dr dt and a dh dt, which is going to make this calculation a little bit complex. So here's where we want to simplify things for ourselves. If we're going to have to take the derivative and we have 2 variables, but we happen to be told a relationship between those 2 variables, like we see over here, then we should be super psyched because that means that we can use a little bit of substitution. We know that the height is equal to 3r. And so we don't know a value for dh dt. If we look at what we have listed on the board, we only have dr dt. So if we can substitute in for h in terms of r, then that means that dr dt will be all that we need in order to solve for dv dt. So let's go ahead and try that on this question. Your volume is equal to 1/3 pi r squared h, but we can substitute in place of h 3r. That's something that the problem gave us directly. So this makes our lives much easier for a lot of reasons. First of all, we're down to 1 variable. And second of all, check out what happens with the 1/3 and the 3. When we go to simplify, those cancel out, and our volume simplifies to pi r cubed. So now when we go to take dv dt, our job just became a lot easier. We have dv dt is equal to 3 pi r squared times dr dt. And we have a value for r that we can plug in. We have a value of dr dt that we can plug in. We have those values written over here. And so then the only missing value will be dv dt, which is what we're being asked for in the question. So we can go ahead and plug in and see what we get. 3 pi times r is 6. So we're going to plug in 6 squared. Dr dt was 2. So we're going to plug that in. Going to do a little bit of math here. I didn't calculate this ahead of time, so I'm going to try to do it in my head. Please don't make fun of me if I miss on this, but 6 squared is 36 times 2 is 72 times 3 is 216. So this will be 216 pi, and most of the time you'll be able to leave your answers in terms of pi. Unless you have a teacher who specifically requests that you find the exact decimal value, most of the time you'll be able to leave it in terms of pi. So dv dt will be 216 pi. If you want to just confirm the decimal answer for that, that'll be posted in the answers portion of our blog for today's calc videos. For more, please feel free to check out our website, and thanks for watching.